Okay, example 3, number 13. This is 5-4, right? Special right triangles. A rhombus is a special type of what? Special quadrilateral, even more special. Yes? Yeah, a rhombus is a parallelogram. It's a special parallelogram, meaning all these sides are parallel, or this is parallel to that. That's parallel to that. It's a parallelogram, but in a rhombus, we know all sides are equal. Okay, so all of these measure 5 units. All right? Now, if I'm finding the area of a parallelogram, how do you find the area of a parallelogram? Tell your neighbor. Okay, volunteer. Area equals what?
Base times height.
Yeah, base times height. Base times height. So, depending upon how I look at this parallelogram, everyone's right here. If I look at it like that, my base is 5. If I look at it like that, my base is 5. No matter what, my base is 5. These are 5 up here. That's 5. Now, if I know my base is 5, and I want to find area, the only other thing I really need to know is the height. Now, height is a right angle height. It is not a slant height. So if I twist this parallelogram and look at it like that, I say, well, this is 5. My height is a right angle height going from this side to this side. So going from one side to another, hitting it at a right angle. So maybe you drop an altitude like this, seeing a right angle, or you go from here to that side at a right angle. It doesn't matter. Either one could be your height. And they're actually the same length. Now, if I'm looking for h, and I just focus in right here at this side, how could I find that length? Go and talk with your neighbor about it. Hey, volunteer, how do I find that length? Chase?
Would 5 be 2x? So we divide it by 2 to find the base.
Good.
The smaller triangle.
Good. So if you're looking at this triangle right here, my coloring again, that was pretty good. Okay. If I look at that triangle right there, 5 is actually equal to 2x. Okay? Which means 1x, which is this length right here, is 2.5. H is equal to, that's equal to x root 3, which is 2.5 root 3. So our height, it's really hard to see there. There we go. Our height is 2.5 root 3. Okay, so that's how special right triangles can help us out there. You get 2.5 root 3. 5 times 2.5 root 3, well, 5 times 2 is 10. Half of 5 is 2.5, so that's 12.5 root 3s. All right. We're going to just go ahead and leave it in that form there. And that would be square inches because we're dealing with area. Questions on that? I want you guys to try number 14. Work with your partner. Hey, my fault for not reading the directions there. It says round to the nearest square inch. So we actually got to calculate the root 3. So 12.5 times root 3 is what? 21 point what? 7 what?
It's actually 6, 5.
Okay, 6, 5, blah, blah, blah. All right. And so to the nearest square inch, we'd have to round that to 22. We'd look at the 6. That makes that go up to 22. Good job. Okay. Thank you for pointing that out. So now try number 14. 14 is that guy right there.
So you couldn't put it in 6 root 3, you'd have to turn it in decimal. So that's how I got 10.4. So that one I actually, that was.
Okay, 12 equals 2x, so 1x is? X is 6, so that links 6. That makes this 6 root 3. 6 root 3 times 12 is 12 times 6, or? 72 root 3, which becomes?
125 inches, or about 125 inches.
Actually, 125 square inches.
Yeah, that's what I meant.
Good. How many got it? Very good. Any questions?
It's actually easy.
All right. I want to go ahead and score up yesterday's. Okay. Let's take a look at that. Which side are we on? Number 5? Okay. So on number 5, this side, we know that we have a 45, 45, 90 because this side is congruent to that. So we have an isosceles triangle. That means these both have to be 45. So we're using properties of that special right triangle. If we label this is length x, this is length x, and this is length x root 2. So to get, this is the equation we can solve. 28 equals x root 2. Divide both sides by root 2. You get 28 root 2, or 28 over root 2 equals x. And then multiply by that special number 1, or that special number 1 is just root 2 over itself. So root 2 over root 2, which gives you root 2 times root 2 in the denominator becomes root 4, which is just 2. All right, so we get 2 as a denominator, and then 28 root 2 on top. That equals x. 28 divided by 2 reduces. You can reduce if both things are outside. So these are both outside of a radical. If one's outside and one's inside, you can't cancel. But 28 divided by 2 is 14. So that's 14 root 2 over 1, or just 14 root 2. That's what x equals. Yeah?
I'm kind of confused on number 6.
Number 6, same page?
Yes.
Okay. Number 6 right here. If we kind of split those in half, triangle in half, one side is 30, 60, 90, the other side's 45, 45, 90. Okay, so we've got that. If I just look at it like that, this is length x, which is kind of confusing because maybe change your variable. Let's call that y or something. Okay, if that's x, this length over here is 2x, so 2x would equal y. That side's x, and this side is x root 3. So this is the side we can solve. We know x root 3 equals 14. If we go through and do the math there, divide both sides by root 3, we get 14 over root 3 equals x. Multiply by that special number 1 again. So root 3 over itself. Root 3 times root 3 is 3. And this is 14 root 3 on top. And so x equals 14 root 3, meaning this is 14 root 3 right here. Over 3. So to double that, when we multiply this by 2 to get 2x, it's 14 root 3 over 3 doubled. So times 2, that's just like having a 2 over 1. So it just doubles the top. So that's 28 root 3 on top over 3 on the bottom. So that's this side. Okay. Maggie? Or excuse me, Hal?
Number 14, I got confused in like the x value, like the line in the two triangles.
So on this one here?
Yeah, so once you find like y and z for the 63 and 90 triangle,
Yeah.
can you use x for the 45, 45, and 90 triangle that you found?
Yeah, so you could, yeah, you're right. You split it up like that. So you have a 30, 60, 90. And then you split it up like this, so you have a 45, 45, 90. And so if this is 5, that means this has to be 5. right? Because they're the same length, and this one is 5 root 2. And so now using that information, we can cover up this side of it and go, well, I know x there is 5. And so if I'm looking at this triangle right in here, I just like coloring. Okay. So if I'm looking at just that triangle, then that ends up telling me that this is your 5 is equal to your x root 3. And so you'd have to solve from there, right? Which is going to tell you this side. You're going to solve for x, which will be this. And then this is twice that. So it's a little confusing because we're using x there. So like maybe you called this, like if you change that letter a so we don't get confused. Okay, so 5 equals x root 3, so that's going to be 5 root 3 over 3 equals x. So that means this right here is 5 root 3 over 3, and this is twice that, or 10 root 3 over 3. Okay? Good. Other questions? Yeah? Okay, so 15, you got to look at it, and we'd have to sketch this side down right here. And the benefit of doing that is you're now making a right triangle. Oh, thank you. Okay, so if you sketch that side in, you now make a right triangle, and you know this length of it. That's 2 root 3. And this is a 60, 90, so that makes this 30. So it's 30, 60, 90. Right? So using your, labeling your pieces, that's x, that's 2x, that's x root 3. The one we can solve is this. In fact, since that says 2 root 3 and this says x root 3, what's the only difference? The common piece is the root 3's. The 2 has to be, x and 2 have to be the same. You shouldn't have to do much math there. Just to make those look identical, that would have to be a 2. Which means x is 2, which means this side is 4. Because it's 2 times 2. Okay? And then, if we know that this is 2 and this whole side's 5, that makes this 3. Good. Other questions? Now it gets a little messy when we're scratching it out up here, but trying to go through them fast now. Hey, Zach, you can grab your test right there, man. Izzy, you can grab yours. They're right on top of the thing there. Yeah?
How do you know where to put like x or 2x or x root 3 on which side?
You guys have to get in the habit of sketching your triangles out so you know where to put the different pieces. So, you know, in your 30, 60, 90, your longest side is your 2x, your shortest side is x, and this is x root 3. You have to come up with a method that's going to help you remember it. I can tell you the shortest is x, the longest is 2x. That's the best I can do. That's why I tried to relate it yesterday, if you remember, to an equilateral triangle. So like this side and this side has a 2-to-1 ratio. Okay? Versus your 45, 45, 90, hopefully you would recognize if you draw 45, 45, 90 that these two sides are congruent. So if we call that one x, this one's x root 2. In fact, what I've told students in the past on these is like, if you're counting, the coefficient here is 1, so it's like you have 1, 2, 3. This one is 1 plus 1 is 2. I don't know how, I mean, if you're mixing up the root 2 and root 3 and which one goes with which, that might be a way to help. But
See, it's easy on that one, but it's that one that,
this one?
yeah, that would mix up sometimes.
Yeah, 1, 2, 3. Yeah. Sketch them out on your paper each time you use them. Other questions? Okay.
Is it still the one?
I want you to go ahead and get that turned in, please. Make sure you grab your warm-up on the way in.
Oh,
Here's your quick warm-up, and I don't want to spend a lot of time on this. I'd like to go maybe 2 minutes per problem, if that. Okay? So here in about 2 minutes, I'm putting up the answers for number 1 here. Okay? About another 2 minutes, number 2. Okay? So you get going on it, try it on your own, and then check with your neighbor. It says some triangles are special, some aren't. Is this one special? Yeah. What is A? 60, right? We've got 90 and 30. So this one has to be 60 to make 180. That is 60. Letter B. Well, in a 30, 60, 90, this side is equal to x. This one is 2x, and this is x root 3. So if x is 9, b is 9 root 3, and 2 times 3, or 2 times 9 is 18. All right. So plug in x for each of these. How many got it? Neato burrito, all right. Another minute or so, and I'll go through number 2 with you. Here we go. D is, since this is congruent to that because of markings, this is 45. 45 are right there. If that's 45 and a 45, 45, 90, E and this are both equal to x. They're the same value, so that is 11. And this is x root 2, so if x equals 11, that is 11 root 2s. How many got 11 root 2? Well done. How many are done with 3? So a lot of you were done with it as I was walking around. Okay, is this one special?
No.
No, I mean it's a right triangle. It doesn't have a special angle, so don't get confused. It's on your quizzes and your tests, some are going to be special, some aren't. So you got to know when you're dealing with special ones. So in this one, how do I find G? Hallie? Good. Yeah, use that cool theorem. Okay. A squared, if we call that A, plus B squared, so we get 144 plus 400 equals G squared in this case. Okay, so 544 equals G squared. So G is root 544. Oh, yeah? Did I mess? Oh, I messed up. Unbelievable. Sorry.
Oh man, I just erased it all.
Don't erase. You gotta say something, man. I messed up. What mistake did I make? And I didn't make that one on purpose. I do sometimes, but not that time.
B is supposed to be C.
Yeah.
B should actually be G.
Yeah, this should be our C, right? Our longest side. Unbelievable. Thank you for pointing that out. So A is 144. And B is going to be our G. So this is our B. All right. Thanks for holding me accountable. So G is equal to G squared. G squared is equal to 256? So 1G is 16. That makes it a lot easier anyway. All right, 16. Good. Hope you didn't erase it all.
I just rewrote it.
All right. Any questions on those 3? How many are done with 4? Okay. Is 4 special?
Yes.
Yeah. Okay, these markings mean these are congruent. H and I, if this is x and this is x root 2, which means in this case, hopefully we know the pattern now. Here x equals 30 root 2. 30 root 2 over 2. Or, good job, 15 root 2. So if this is if x equals 15 root 2, that means that equals 15 root 2 and that equals 15 root 2. So we use what we know to solve for our variable. How many got it? Well done. Is number 5 special?
No.
No. All right. A squared plus B squared equals C squared. All right. Well, there's A. There's B, and I know I'm correct this time. This one's C. Okay, so 4 plus 100 equals J squared, or 104 equals J squared. Oh. Oh, man. Darn. Now that time I actually did make that mistake on purpose. Except for I should have used my pencil. All right. Make sure you remember to square 116. So I'm done, right? J equals root 116. Yeah? No. Yeah, what do I need to do? I need to simplify. Okay? What perfect square goes into it? 4. Root 4 by 29. Yeah, now that's not one that you usually think of. Hopefully the 4 comes to mind. 29 doesn't necessarily, though. So that gives us 2 root 29er. All right. Way to go, Jay.
I'm remembering algebra. It's
See what I did there?
It's like
All right.
always mess you up because
I know.
simplifying them.
All right. Number 6. Special?
Yes.
Yes.
Oh, yeah, if this is 60 and that's 90, this makes this 30. All right. Okay, so in this one, this is, well, let's go with this. What's this? The shortest side is always
X.
x. The longest side is always 2x. That means the last one is x root 3. All right, well, that looks ugly.
Oh man.
4 root 5 equals x root 3. I know. That's tough. So, we've got to divide by root 3, right? So we end up now with 4 root 5 over root 3 equals x. Can't have a root in the denominator. So we multiply by the special number 1, which is
3.
root 3 over root 3. Multiply by that. So 4 root 5 times root 3, and then root 3 times root 3. So root 3 times root 3 is 3. 4 root 5 times root 3 is?
4 root 15.
Yeah, you multiply the common parts, the roots. Okay, so that's 4 root 15s. Can we simplify 4 and 3? No. That's it. That is L. That's what x equals. And we know x equals L. Therefore, that is L. So 4 root 15 over 3. Holy moly. How do you do twice that?
Multiply by 2.
Yeah. Yeah. 2 over 1 times x. So x is 4 root 15. So most of you just get in the habit. You're like, well, that's just, you double that. So that's 8. So now I have 8 root 15 over 3. How many got that? Yeah, Mano. I know. Then there's this accusatory story problem. I had 3 pieces of red licorice, I meaning Mr. Vogel. That made a right triangle. Mr. McCoy got hungry after school and ate a piece of one of the legs. What a jerk. I know. He wouldn't even give me the full piece of licorice. Can you believe that? Yeah. All right. So we have this licorice. It was the special blue licorice, blue raspberry. Okay. Made a right triangle. Okay. I got hungry and ate one of the legs. What kind of triangle would it be now? So we take, and I ate this piece right here. I remember. How do I make that into a triangle? Chase?
You move it over and you move the
Good, so the leg that stayed the same, so if we called this B, that stayed the same. This leg has to now, does it slide inward or outward? Outward. Yeah, it has to slide outward. All right. So now I have an obtuse triangle. Okay, this little chunk is our A now. Huh? Can't be right anymore because I took a part of it off. Yeah. Unfortunately, yes. Sad, right? Or obtuse? Okay, questions? Remember, what you're looking at here is, if you recall, this was c squared equals a squared plus b squared. And if I take part of a off, that means this part over here is going to be smaller than that now. So that means c squared is going to be now greater than a squared plus b squared. Remember, if c is greater, it's obtuse. If c is lesser, then it's acute. If they're equal, then it's right. Okay. Your assignment today is the review. The review and pre-quiz. It'll get you ready for your quiz. All right? Do your bestest. Be ready. We'll correct it right before our quiz tomorrow. Be